Welcome to today's video lecture on cost and profit maximization using the example of Savvy Spice, which is the company that produces gourmet spices. We'll go through a series of calculations to determine the company's costs, revenues, profits, and other financial metrics. So let's dive right. So here we have some kind of given data. Let's summarize the information we have. Fixed cost, $800 per month. This includes warehouses, rents, and equipment maintenance. If I talk about the variable cost, the data provided show that the company spends $4 per one jar, which includes raw spices, labor costs, and packaging. The company is planning to sell each unit of production, each jar, for $15 per one jar. The company is aiming to produce 600 jars these months. So all your calculations should be based, most of your calculations, on monthly basis. So step 1. Let's calculate total cost and total cost per unit of production. You remember that total cost include both fixed and variable cost. The formula for total cost is total cost equals fixed cost plus variable costs. So here we have $800 plus $4 multiplied by 600 because the company is aiming to produce 600 jars. As a result, we have this number $3,200. This is the metric of the total cost. If I talk about the average total cost per unit, we can define as the total cost divided by the quantity produced. In other words, total cost divided by the quantity produced. $3,200 divided by 600 gives us $5.33 per one jar. In other words, an average total cost per jar is $5.33. Step number 2, determining total revenue. Total revenue is calculated by multiplying the price per unit by the quantity sold. The formula is price per unit multiplied by quantity sold, which gives us $15 multiplied by 600 equals $9,000. So step number 3, calculation of profit. Profit is the total revenue minus total cost. So TR minus TC, $9,000 minus $3,200 gives us $5,800. Here we have to calculate something which is called a break-even point. In other words, it's a quantity at which total revenue equals total cost. In other words, this is the quantity after which, exceeding which, the company starts to make profit. It equals fixed cost divided by revenue per unit minus variable cost per unit. So here we have $800 divided by 15 minus $4. In other words, $800 divided by $11 gives us 72.73 units, or roughly 73 units. In other words, after 73rd jar produced, the company starts to make profit by producing an additional unit of production. So at this level of production, at this level of jars produced, the company revenues equals its costs. With their current production, as it's written right here, they're of 600 jars. Remember, they are well above the break-even point, and they are generating a profit of 5,800. For profit maximization, we use the concept of marginal revenue (MR) and marginal cost (MC). We remember from the beginning of the task, or in the section where the data has been provided that MR equals $15 while MC equals $4. So remember that the conventional condition for profit maximization is MR equaling MC. Since MR is greater than marginal cost, producing more units will increase profit until MR equals MC. However, in this case, we know that the given constant MR and MC indicate that company can produce more, or even the production of more units is more than welcome, because every additional unit would bring more money to the company. So it's going to be quite, or not quite, extremely profitable enterprise. Scenario analysis for increased demand. So let's consider that the scenario where the demand increases and the company produces 900 jars. So here we have something which is called the increase in the production up to 900 jars, and we need to calculate the new total cost, average total cost, total revenue and profit by following the similar, absolutely the same formulas we have been utilizing in the first and second steps of our calculation task. So then, given the new quantity, we have the new total cost up to of $4,400, average total cost of $4.89, since we can spread the total cost over the large units of production. This is something which is called economies of scale. And total revenue of $13,500 and new profit of $9,100. In other words, if the company produces and sells all 900 jars, the profit would be $9,100, which is $3,300 higher than the original's profit in the first scenario. The scenario number 3. Suppose the price per jar increases up to $18. In this case, we need to calculate the new break-even point by following this formula, the original one. Break-even point in this case is calculated by dividing the fixed cost divided by revenue per unit minus variable cost per unit. Absolutely the same numbers, only one change in the revenue per unit. We need to insert 18 instead of 15, which gives us 800 divided by 14, which gives us roughly 57 or 58 units. The interpretation is pretty easy. So the service price in this scenario needs to sell approximately 58 jars to break even with the new price. So the increased price usually decreases the break-even quantity, showing a reduced risk and increased profitability. However, in this case, we need to understand if, but it's not provided in this task, the elasticity of demand. So in real life, you should ask yourself, would the increase in the price distract a lot of consumers from your service or from your good? But in this case, there is no need to take this into account. So this is the end of this task. So pretty easy. This video has been made to refresh the algorithm you need to utilize in your future calculations throughout your studies in the second year of your education. Many thanks. Thank you for your attention. The video guide to refresh the algorithm to solve the second type of task that involves some kind of mathematical calculations dealing with the supply and demand curves is presented right here. First of all, please familiarize yourself with the equations of demand and supply. Try not to confuse them. That sometimes happens with the freshmen. So please be cautious and pay attention to these letters QS and QD. You have to calculate the equilibrium price and quantity for smartphones without any government intervention. So let's start from this. So the basic idea of this task is to analyze the impact of the government who is thinking about implementing a specific policy to affect this market. In this case, we have the market for smartphones, where the quantity demanded is presented by this equation. QD equals 1800 minus 2p, and the supply equation of 500 plus 6p. So step the calculation of the equilibrium price and quantity. Equilibrium in the market occurs where the quantity demanded by consumers equal the quantity supplied by producers. In other words, this is a point that determines the market price and quantity of goods sold. So the basic idea of this subtask is to calculate the equilibrium price and quantity for smartphones without any government interventions. No subsidies, no taxes are imposed right here. So we have the demand and supply equations and the equilibrium price in this case. So we have one variable at the point of intersection of these two curves. So we have just to equalize them, which gives us 1800 minus 2p equals 500 plus 6p. Here we have 8p equaling 1300. So by dividing 1300 by 8, we receive the equilibrium price of $162.50. So the equilibrium price is $162.50. The second subtask is to calculate the equilibrium quantity. So the basic idea is just to substitute price back into either demand or supply equation. Doesn't matter, because the equilibrium is the point of intersection of these two curves. In other words, they are equal in this particular point. So we just picked the equation of demand and just substituted P, which gives us 1800 minus 2 multiplied by $162.50, and in the end we receive 1475 smartphones or units of production in this case. So the equilibrium price in $162.50, the equilibrium quantity is 1475 units. So the step number 2. In this case, there is the impact of the state. A tax of $25 per unit sold affects the supply side because it's the tax on the supplier, because it increases the cost for producers. This shifts the supply curve upward by the amount of the task. So in this modify the supply curve, take into account that the incorporation of the tax on the supplier works in the subtractive manner. In other words, it reduces the effective price which is received by producers. So it's going to be the P minus T, or in this case T stands for the tax volume. We have a tax of 25, so the tax usually moves the supply curve upwards. As a result, there is a new equilibrium price and new equilibrium quantity. If I talk about the equilibrium price, it's higher, and the equilibrium quantity is lower than before. So that's how the taxes are working. So they increase the price, so less people are able to afford this kind of service or goods. That usually happens in the industry of cigarettes or alcohol. So the press supply function was 6 plus 20p, just an example, it's not our case, and there is a tax of $5, so it works for every unit of production by the supplier. So we need to utilize the brackets, it's very important. So some people just add -5 in the end of the equation. This is not right. So open up the brackets, p minus 5. So 20 can be attributed to both p and -5. That's how it's working. So open the brackets. It's very important. So we have to modify the supply equation since it's the tax on the supplier on the units sold. We have to modify it taking into account the fact that the tax is $25. So 500 plus 6, open the bracket, p minus 25, we close the brackets. So here we have the new equation of QS equaling 350 plus 6p after easy mathematical calculations. Ta-da! So in this case we have to find the new equilibrium price and equilibrium quantity, take into account the new modified supply equation, take into account the fact that the original demand equation stays absolutely the same because there was no any kind of impact by the state on the demand side. What has been influenced by the government is the supplier. So we just equate these two equations and receive the new equilibrium price of $181.25. That's how the taxes are working. They increase the price so less people can afford this, which motivates people to give up an idea of purchasing this kind of product. Again, cigarettes, alcohol. And the new equilibrium quantity can be found by substituting P in any of these equations because they in the equilibrium point absolutely the same. So Q equals 350 plus 6 multiplied by 181.25, which gives us 1,437.5 units. So this is the answer when we experience or when the industry experiences the intervention of the state in the form of the tax. In other words, the imposing of the tax per unit sold on smartphones has several notable effects on the market equilibrium when compared to the scenario without any. First of all, there is an increase in the equilibrium price. So tax leads to increase in the market price because the tax effectively raises the cost for producers who definitely have to pass the portion of the cost on to consumers in the form of higher prices. So since the price is higher, we experience the quantity of smartphones decrease from 1,475 units up to 1,437.5 units. This decrease is quite typical in various scenarios when the tax is imposed. And also please pay attention that usually the introduction of the tax tend to create something which is called the deadweight loss, or loss of economic efficiency, which takes place when the equilibrium outcome is not achieved. On the other hand, the government may generate the revenue to fill the national budget by receiving the tax payments in order to provide the public services and mitigate the externalities. So this is the reverse side of the medal. So the second type of state intervention can be in the form of the subsidy. So these interventions can be attributed to fiscal policy of the state. So in this case, the governments, in this scenario, the state provides a subsidy. So it motivates the smartphone producers because they think, for instance, that these smartphones are of the local domestic production and the producer should be rewarded. Usually the subsidy adds directly to the price that producers receive from each unit sold. So in this case, it works absolutely in opposite direction. But please remember, always use the brackets. And this additional income from the subsidy usually increases the producer's willingness to supply more at every price. Because in this case, we have something which is called the law of supply. The more the supplier receives in the form of the payments, the more he is motivated to produce. So first of all, since it's the subsidy on the producer, we again have to modify the supply equation by adding $30 in the form of the subsidy to every unit sold by the producer. So please use the brackets. So the modified subsidy equation would be 680 plus 6. Again, find the new equilibrium price and quantity, absolutely the same logic. So in this case, we just have to equate the new, absolutely new, the second modified supply curve to the old original demand equation, which has been absolutely the same without any kind of intervention. So the new equilibrium price is 140, while the new equilibrium quantity is 1520. So in this case, the people tend to buy more because the price is cheaper. How can you interpret these kind of results? Absolutely opposite to the tax subsidy lowered the market price. For instance, in this case, we observed the decrease of the equilibrium price from 162.5 up to 140. So the smartphones are more affordable to consumers, and as a result, more people can afford them, which increase automatically the quantity sold and demanded, because subsidy encourages producers to increase production to the higher effective price. They are trying to make higher profit. While subsidies also lead to overproduction relative to market equilibrium without intervention, they can also correct market failures to achieve social goals. So in this case, for instance, just an example, the state think that more people need smartphones. For instance, there is a new COVID-19 outbreak, and if the state wants us to come along this issue much earlier than before, they can motivate the local smartphone producers to produce them and sell at lower price by allowing the most of the population, for instance, to afford this kind of smartphones. But also remember, opposite to the taxes, the subsidies are the form or unlike taxes, the subsidies are the form of the state expenditures. So the government needs to spend money wisely to fund the subsidy, which could be substantial depending on the market size. Because it's a price floor. So what can we drive in the form of conclusion based on these calculations? So the demand for smartphones at this price drops to 1,400 units because it's definitely higher price which discourage some consumer from purchasing. So suppliers are willing to offer just 1,700 units at this price of How can you interpret this kind of result? The price floor is set above the equilibrium price leads to a deadweight loss, representing the loss of economic efficiency in the markets. Usually resources are mislocated in economy because definitely there is a surplus of smartphones in the market. Sometimes government may assist such companies which experience the surpluses in order to sell their production units somewhere else in the foreign country. The variant number 4 or scenario 4, in this case the government sets a price ceiling, in other words the maximum price the producer can charge for its product or service. Your task is to determine whether this price is binding or not. And what is the interpretation of this result? So absolutely the same logic. We need to substitute the P variable by the new price, and here we have the result of QD and QS. Given the price of 150, the quantity demanded is 150 and quantity supplied is 1400, excuse me, 1500 and 1400 units. And you remember that the equilibrium price in the original one was $162.5, and definitely since the price ceiling is below the equilibrium price, it's automatically binding. It means that it restricts the price from reaching the equilibrium level. If it had been higher than the equilibrium price, all the transactions would be made at this price. How can I interpret this result? This results in market shortage of 100 units where not all consumers who want to buy the product at $150 can find it available. In other words, imagine there is a smartphone, iPhone, the new brand, which comes at discount of 20%. Definitely, it would spark the demand, and there would be long lines, long queues, wait lists, and definitely all the people would not be able to purchase the iPhone. So in other words, there will be definitely the person who would be left without an iPhone, which would be leading to the feeling of frustration. That what usually happens within the times of Black Fridays, when people are fighting for the new brand PlayStation. The market does not reach an efficient allocation of resources due to price ceiling. In other words, the shortage implies that there are consumers willing to pay more than 150 for the product, but the producer willing to sell at prices above 150, but they cannot do it legally. If they don't want to do this legally, they may form something which is called the black markets. So, step number 3. In this case, we need to calculate the price elasticity of demand. So you remember that price elasticity of demand measures how responsive the quantity demanded is to change in a price, or if it's the quantity supplied to change in a price. If I talk about the price elasticity of supply, we remember that the original equilibrium price was 162.5 and the original equilibrium quantity was 1475 units. Okay, this is a conventional traditional price elasticity of demand formula, resemble the price elasticity of supply. The basic is not to confuse the equations, so if you have to calculate the price elasticity of supply, work with the supply equation. But in this case, we're going to be utilizing something which is called the midpoint method, which uses the average or the midpoints between two data points to calculate the percent change in the price of goods and its percent change in quantity supply and demanded. So from the first glance, this kind of formula may look quite challenging. It's much more easier because all the calculations can be made in one row. We need to find the change in quantity demand and divide it by the average quantity demanded. We receive here the variable 1, for instance. Variable 2 is represented by the change in variable in price divided by an average price. This is variable 2. And as a result, you have to divide variable 1 by a variable 2. Just an example. Imagine there is an initial price for a smartphone at the level of $300. The due price is $350. So since it's a price elasticity of demand, we're working with this formula. We need to insert this value instead of B and receive the new numbers. So in other words, if the price is 300 per one smartphone, the quantity demanded is 1,200 units. And logically, if the new price is $350, the quantity demanded is 1,100 units. Logically, yeah. So the law of demand is obviously working. The higher the price, the lower the quantity demanded. So we need to insert all the received data into the midpoint formula. 1100 minus 1200 divided by 1100 plus 1200 divided by 2. It's an average value, ladies and gentlemen. Absolutely the same is with this line. So here we receive something which is called the coefficient, elasticity coefficient. We do not have to pay attention to this sign right here. We're interested just in the mere value. 0.55 56 for instance. Yeah, anyway, it's between 0 and 1. In other words, the demand for smartphones is inelastic, indicating that consumers are not very responsive to price change. What does it mean? Since demand is inelastic, a price increase could lead to increased revenue without significantly reducing the quantity sold, benefiting poor producers. There is a supply price elasticity presented by midpoint formula. Absolutely the same logic, but in this case we're working with the QS instead of QD. Many thanks. I hope that this kind of video lecture assisted in the refreshment of your knowledge. Thank you. Have a nice weekend.